So in 7.4, we're taking a closer look at radical expressions and really focusing on how we can simplify and even combine them. So effectively, we're trying to determine what makes radical terms like terms, things you can put together. And it boils down to simply the radicals having to have the same index and the same radicand. So again, that's the fancy name for the inside of the radical. So the idea here, when you look at terms like this being a fifth root of 3, right? All of that is essentially the thing that needs to match another term, like here, fifth root of 3. If those match, those are considered like terms, and then it's what's out front that actually gets combined. Very similar to the way variables made like terms, right? If you had x terms, 4x and 2x, the x is what made them match. Those are like terms, x terms, combine the 4 and the 2 to get the 6, right? So that's the main idea. I do want to point out up here in the mixed trick, it does mention something important. When looking for like terms, do definitely look to simplify any radical before you bother combining them. Meaning if this was something we could reduce or simplify like we saw in previous section, we would do that. But once these match, they can be combined. So this would give us 6. And then notice the fifth roots of 3 does not change, right? That's what made them like terms. That's the kind of term they are. So that's the kind of term you get when you combine them. So with that rule, let's take a look at some examples. We've got this first one, 3 root 8 or 3 times the square root of 8. So again, your approach that you take is up to you, whether you're looking for the factor that's a perfect square in there or you're just breaking it down. I'm going to keep using that approach. I think overall that's the simpler approach for students to adopt. So I'll break down 8 into 2, 2, and 2. And so since this is a square root, remember we're looking for pairs. So right there is that 4 or pair of 2s. So that will come as a 2 outside, that 2 will stay inside. So this term turns into 3 times, and we'll just for right now say the square root of 8 is 2 root 2. Again, 2 comes out, 2 stays in. Minus 6 times, all right, let's look at the 50. Breaking apart the 50 to 2 and 25, and then 25 is 5 and 5. So that's what 50 breaks down to. Well, there's a pair of 5s. 5s will come outside, 2 will stay inside, so the square root of 50 simplifies to 5 root 2. Plus 2 times, and that will break down to 100. Okay, 200 can break down to 20 and 10, 20 to 2 and, 2 and 10, 10 to 2 and 5, and then another 10 to 2 and 5. So I'll write that down here. 200 has now simplified to, looks like 3 2s and 2 5s. And that means we've got a 2 there, we've got a 5 there, right? That will come out of the 2, out of the 5, with a single 2 left inside. Now if a 2 and a 5 are both coming out, 2 times 5 means we've got a 10 that just came out of there with a 2 left inside. So I went through that kind of quickly. Again, if you haven't really mastered simplifying radicals from 7.3, certainly go back and practice that, or just go back and watch this a couple times to see that, progression there of those 3 being simplified until that really, really makes sense. This is something we got to make sure we can do, whether it's this approach or the finding perfect squares approach. But now, we've got 3 times 2 root 2, so that's going to be 6 root 2. That 6 and 5 will give me a 30 root 2, and that 2 and 10 will give me a 20 root 2. Now notice, with all that simplifying we finally did, we can look at these as square root of 2, square root of 2, and square root of 2. Those are all now like terms, right? It's the same index, square root, and same inside 2. And so these can all be combined, and I'm looking at 6 minus 30 plus 20, so that'll be a minus 4 square root of 2 for my final answer there. All right, number 2, we're looking at fourth roots. Right now they definitely don't match, but let's see if we can break them down. Again, with fourth roots especially, I feel like not many students are going to have recognized or memorized their perfect fourths, so this is another reason why this approach works nicely. If I go 4 and 8, and then 2 and 2, and then 2 and 4, and 2 and 2, right? That's going to break down 32 completely for us. And so that's 1, 2, 3, 4, 5 twos, right? 1, 2, 3, 4, 5 twos. A fourth root means I need a group of 4 of them to bring out a single 2, right? That's 2, 4, 8, that's a 16. The fourth root of 16 is 2. That's why that comes out as a 2, that stays in there as a 2. So we had a negative 2 out front, and then this turned into 2, fourth root of 2. Now minus 7, and we'll look at the fourth root of 162. Okay, so 162, it could be a 2 and an 81. 81 is 9 and 9, and 9 and 9 is a bunch of 3s. So there would be my breakdown of 162. And there's a group of 4 3s. So a 3 can come out front, and a fourth root of 2 is left inside. From there, negative 2 and 2 gives me negative 4, fourth root of 2. That'll give me minus 21, fourth root of 2. And notice now they are both fourth root of 2 terms, so we can combine what's out front and get negative 25, fourth root of 2. All right, next one. All square roots, but definitely not same insides. So if we start with the 80, break down 80, I'll go 4 and 20. 4 is 2 and 2, 20 is 2 and 10, 10 is 2 and 5. So 2, 2, 2, 2, 1, 2, 3, 4 2s, and a 5. Being a square root, I need pairs. There's a pair and there's a pair. So each of those will come out as a 2, meaning a 4 will come out front. Now, let's go ahead and talk about what else comes out front, because there's an m squared in there. M squared is 2m's. We need a square root. The square root of m squared would just be a single m, right? You're looking for pairs of m's, and there's exactly one pair. So that m will come outside, and notice there will be no m's left inside. So the only thing left inside is going to be that root 5. Okay? Next one. Let's break down 125. 125 would be a 5 and a 25, and then 25 would be 5 and 5. So there's 125. There's a pair of 5s, so that pair of 5s will again come out front. Looks like we've got another m squared inside, which means that will simplify to an m on the outside, and we've got a single 5 left on the inside. And last one is 20. Break down 20 to 4 and 5, 4 to 2 and 2. So 20 is 2, 2 and 5. We've got a pair of 2s that will come out. Again, square root of m squared will give us an m, and we're left with that 5 on the inside. And so the point of this one, besides, again, lots more practice and simplifying, the point here is these are all square root of 5s, right? Square root of 5, square root of 5, square root of 5. So they're like terms. What's important is if you look out front of them, those are actually also like terms, because I'm going to combine what's out front of them. If one of these was an m and one was a number, or one was an m squared, the terms themselves couldn't go together. But in this case, 4m, 5m, minus 2m, giving me 7m outside of the square root of 5 for our final answer there. All right, next one. So real quickly here, just to point this out, this can be tricky, especially if you're looking in something like MyMathLab to tell the difference. This 3 right here, determining if that's a cubed root or an x cubed, very important in this problem. Now notice, one way to, by contrast, understand what this is, does this 3 look like it's at the same location as this squared? No, right? X squared has the 2 up here. This 3 would have to be higher if this was an x cubed. Now, when I'm writing it by hand, I always try to separate them more. I also try to put the index more kind of inside of this, like the valley of the radical symbol. But when it's being typed, that's kind of how it's going to look. So just pay attention. Also, when you're writing, pay close attention. But that is a cubed root symbol there. So look inside the cubed root. Cubed root of x squared y. So we need three of a kind, groups of three, but we only have two x's and we only have one y. So this will not simplify at all. There's nothing else to do to that. That's going to remain 3x cubed root of x squared y. And notice, like I said, when I write it, I try to make this a little bigger, put the cubed inside there so it's not too close to the x. That didn't simplify at all. Let's look at the next term. Cubed root of 8x squared y. Well, again, x squared y, nothing's going to happen there, but 8 cubed root of 8, hopefully we can start recognizing that as a 2. This will work out nicely, completely, nothing left inside. Cubed root of 8 will bring a 2 out. There's already a 2 out there, so that'll turn that to a minus 4. The x is still out there, but then we have the cubed root of, well, that just got removed. So just x squared y inside. And notice after that simplifying, now we've got cubed root x squared y, cubed root x squared y. They match. So looking out front, 3x minus 4x is just a negative 1x with that cubed root of x squared y as there being like terms. So that would be our solution, our simplification, I should say. All right, and last one. First is we got 2 times the square root of 12. So we got to break down 12, 2 and 6, 2 and 3. So there's 12. It's a square root, so we want a pair of 2's. That'll bring a 2 outside. There was already a 2 out here. If we bring another 2 out, that'll turn that into 4 times the square root of 3. Next term, minus 2 times the cube root of 24. Okay, well 24 is 2 and 12 and 2 and 6 and 2 and 3. So 2 times 2 times 2 times 3. But notice this was a cubed root, so we need a 3 of a kind for that 2 to come out, and the 3 will stay inside. If the 2 comes out and there was already a 2 there, that will be minus 4 again, but cube root of with the 3 left inside. So we get to here, and now is where we want to point out that we just simplified them. However, one's a square root of 3, one's a cube root of 3. Those are not going to be like terms. Those are not things we can put together. In this case, the indices don't match. So that would be the extent of what we could do there. So just watch for that rule, very specific. It needs to be the exact same index and radicand to combine like terms.